All right, let's dive right into this explainer on how psychologists first tried to literally put a number on human intelligence. We hear the term IQ thrown around all the time, right? Used as shorthand for how smart someone is. But where does the actual math come from? Today, we're unpacking the origins of psychometrics, focusing on an English psychologist named Charles Spearman. We're going to break down his massive two-factor theory, which honestly kickstarted the entire modern conversation about human cognitive ability.
Think back to your school days. You probably noticed a pattern, right? Why is it that the kid who absolutely crushes it in advanced calculus also tends to ace literature or history or foreign languages? Is it just lucky genetics? Do they just study way harder? Or is there some centralized hidden engine powering the brain across all these totally different tasks? That is the core mystery we are solving today.
Here's the roadmap for this explainer. First, the mystery of intelligence. Second, the two-factor theory itself. Third, how we measure mental energy. Fourth, test bias and criticisms. And finally, the modern view of intelligence.
Okay, part 1, the mystery of intelligence and the positive manifold.
So to get to the bottom of this math, we have to rewind to 1904. Charles Spearman started looking really closely at kids' report cards. He analyzed a small group of 24 village schoolchildren, and he painstakingly compared their scores across vastly different areas. We're talking translating classical Latin, speaking French, doing math equations, and even physical sensory stuff, like telling the difference between musical pitches or the weight of two objects. And what he found was a total game changer. Kids who did well on a highly academic subject, like Latin, usually scored high in math and even those physical sensory tasks. The correlations were just overwhelmingly positive across the board.
The big takeaway here is a concept called the positive manifold. And this is super important. Think about it. If human intelligence was purely modular, meaning your math brain had absolutely zero connection to your language brain, you'd expect the statistical correlation between those subjects to be absolute zero, right? You'd be great at one, terrible at the other, completely random. But the positive manifold proved that performance measures across all seemingly unrelated cognitive tasks are universally positively correlated. It showed that cognitive abilities are inextricably linked, not completely isolated. And get this, it remains one of the most rigorously replicated results in all of psychology.
Moving on to part 2, the two-factor theory, unpacking G and S.
To explain this positive manifold, Spearman proposed something revolutionary, the two-factor theory. He hypothesized that any cognitive task, no matter what it is, relies on two overlapping elements. First, there's a central, general ability that touches absolutely everything you do. And second, there are specific task abilities, things like mechanical, spatial, verbal, and numerical skills. Spearman argued that these specific skills overlap with that general central core. Basically, you literally cannot perform a specific mental task without drawing on that centralized ability. Let's break these down. Starting with that central core, which Spearman called the G factor, or general intelligence. He viewed this as a sort of innate mental energy. It's kind of like the central power grid in a city. This energy flows through the brain, powering everything we do. Whether you're solving a complex puzzle, debating philosophy, learning how to code, or just trying to remember a phone number, you're plugging into that exact same central G grid. Then you have the S factor, which stands for specific abilities. If G is the central power grid, S represents the highly specific appliances plugged into that grid. These are the task-specific skills and knowledge you need for a particular activity. For example, your unique English vocabulary or the specific spatial awareness you use to mentally rotate a 3D object in your head. Those are completely distinct S factors. They're the local engines doing the specific work, but they still absolutely require fuel from G.
When you put them side by side, the dynamic is pretty clear. The G factor is generally seen as an innate, general mental energy common to all tasks. Meanwhile, the S factor relies on acquired, specific skills unique to individual tasks. Because of this setup, two people with the exact same level of innate G can actually score very differently on a specific vocabulary test if one of them has built up a stronger S factor for language through intense reading and practice. It's general capacity versus specific application.
All right, part 3, measuring mental energy through factor analysis.
Now you might be wondering, how do we actually isolate this invisible mental energy? I mean, G isn't a physical spot in the brain a surgeon can just point to. Well, Spearman actually had to invent the statistical machinery to do it, known as factor analysis. Imagine taking dozens of different intelligence tests and pouring them into a giant mathematical funnel.
Factor analysis basically strips away all those specific S factors, the specific vocab words, the rote math rules, to isolate the shared variance running through all the tests. That distilled mathematical drop left at the very bottom of the funnel, that underlying latent variable, is the G factor.
But what does this distilled G actually predict in the real world? Like, why do we care? The data shows G is a massive predictor of academic achievement, complex job performance, and cognitive throughput, which is basically the raw speed at which you can absorb, process, and apply new information. But, and this is a big caveat, it's a remarkably weak predictor of emotional and social skills. It tells us virtually nothing about a person's relationship quality, their leadership effectiveness, or their ethical behavior. It is strictly a measure of raw cognitive processing power.
Which brings us to Part 4, Test Bias and Criticisms and the Limits of Testing.
As this statistical tool got more popular over the decades, shaping everything from educational tracks to hiring, researchers naturally uncovered some severe limitations in how these tests are designed. Critics point out that test items heavily reflect middle-class Anglo-American experiences. They rely on deep language proficiency, which instantly penalizes non-native speakers, in ways that have absolutely nothing to do with their innate IQ. Plus, these tests heavily favor analytical thinkers who can decontextualize information, which actively disadvantages people who tend to solve problems relationally. Because of all this, scores often correlate heavily with a person's socioeconomic status.
As one prominent critique brilliantly sums it up, the scores on these tests, then, will be as much measures of acculturation and income as they will be measures of ability or skills. This highlights a massive, ongoing debate among sociologists and psychologists. A high score on a traditional ability test might just reflect a privileged baseline of familiarity with the test producer's culture, rather than a true reflection of raw, innate intelligence. It's absolutely vital context when we try to interpret what G actually represents in society.
Finally, Part 5, The Modern View of Intelligence, from Spearman to CHC.
After more than a century of intense scrutiny, test redesigns, and heated debates, we can trace a fascinating evolution in how the scientific community views intelligence today. It started, obviously, with Spearman's single G in 1904. But by 1916, models popped up arguing against a single G, suggesting the brain was just a massive network of unconnected neurobonds. Then in 1938, Lewis Thurston pushed for multiple independent abilities entirely, rejecting G completely. But jump to the 1990s, and researchers Raymond Cattell, John Horn, and John Carroll managed to actually integrate all these seemingly conflicting historical ideas into one unified framework.
The result of that integration is the widely accepted Cattell-Horn-Carroll, or CHC theory. It perfectly synthesizes a century of debate into a massive three-stratum hierarchy. Down at the base, stratum I, you have over 70 narrow, highly specific cognitive skills, essentially Spearman's S factors. Move up to the middle, stratum 2, and you find broad abilities like fluid reasoning and processing speed. And sitting right at the very top, at the apex of the entire model in stratum 3, researchers confidently placed Spearman's original 1904 discovery, the general intelligence factor G.
To wrap up this explainer, I want to leave you with something provocative to chew on. We've seen the undeniable math behind the positive manifold and how G genuinely acts as a cognitive power grid. But we've also seen the serious cultural and linguistic limits of trying to extract that number through standardized testing. So if G is ultimately just a statistical correlation distilled from culturally bound tests, can a single number ever truly define the vast, beautiful, and highly adaptable complexity of human intelligence? I hope this deep dive helps structure your understanding of Spearman's two-factor theory and where the math behind IQ testing really comes from. Keep learning, keep questioning, and we'll catch you in the next explainer.